So now, solving the Hill's equation by this method, we introduce three new parameters, alpha, beta, and gamma. We will see shortly what are the physical significance these parameters have. These parameters are known as twist parameters. And some literature says optics parameters or lattice parameters. Invariant of motion already has been obtained. Now we see the expression of this invariant of motion in some detail. Now you can see that this is the equation in x and x prime. Means there are two coordinates, one is x and another is x prime. X prime shows the angle and x shows the displacement. So these are two coordinates or two variables. So this is the second order algebraic equation in two variables. Means it may show a conic section. So for conic section, we see that gamma beta is alpha square plus 1. Means gamma beta is greater than alpha. This is by the definition of the gamma which we have provided in the next slide. And the particular determinant which we can calculate using this second order algebraic equation, which defines that this second order differential equation is not degenerate, means it doesn't show straight lines. So this shows that really this is a conic section, and this shows that this conic section must be an ellipse. So this equation shows an ellipse. As in the case of simple harmonic oscillator, we obtained an ellipse in the x and x dot. Here in x and x prime, we are getting some ellipse. Area of this ellipse is pi a square, and a square is invariant. Means area of this ellipse is a constant quantity. Means throughout the propagation of the particle in entire optics, due to variation in gamma, alpha, beta, the orientation and elongation of this ellipse may change. However, the area will remain same. So this is a remarkable result in the beam physics. Now we come on the physical meaning of the twist parameters. The physical meaning of beta is very simple. Because in the solution we get x is equal to a root beta, and value of phase part varies between plus minus 1 at any place. Cos phi may be between the plus minus 1. So maximum value of this x is a root beta. Maximum value of a means maximum value of displacement at a particular location S during the exhibition of betatron oscillation by the particle. Means if suppose here we do something. Suppose we take different combination of x and x prime, because these are two variables, so we may have various combination, and these combination, each combination gives the same A. Means these many initial conditions are on the peri of the ellipse decided by this A. And definitely at the location where we are getting this, the twist parameter of that location. So this may be the ellipse. Say S is equal to S location. At S is equal to S. We have certain, this may be the one combination of x prime, this is another, this is third, this is fourth, like this. So this will define an ellipse. Now these particles propagate through the optics. So this ellipse may get rotated, may get elongated, but the area will remain same. Now here you can see the maximum distance from the design trajectory is this, and this is A root beta. So by knowing the beta for a particular invariant of motion, we can find out what is the maximum possible amplitude of betatron oscillation corresponding to that invariant of motion at a particular location S is equal to S. At another location, because beta changes, means say at S is equal to S2, beta changes because beta is a function of S. So at that location, amplitude will also change. And in the case of synchrotron, suppose this is the orbit of a synchrotron and you are looking at S is equal to S2. Means you have a detector which can record the position of a particle which is passing through this line. Then you can record it. So suppose in first term you record x1. After first complete turn, it will come again this particle and you record x2, its position. And in third turn, its position with respect to design trajectory is x3. In fourth turn, it is x4. Like this, you have recorded x1, x2, and up to xn. So what will be the maximum value x you will record it is given by AB. And if you will plot these x1 to xn, suppose this is the number of turn, or here you plot the x, so you will get such kind of motion which is harmonic motion, and these are the betatron oscillations, and the amplitude is represented by A root. So beta actually shows the amplitude of betatron oscillation. So beta has that significance, and definitely we have seen that beta is also related with the phase advance, means local wavelength. Now for obtaining the physical meaning of gamma, that was the third parameter which we introduced. The second parameter is just the derivative of the beta. So second parameter shows you if beta increases means amplitude increases, means beam is diverging. If beta decreases, so amplitude decreases, so beam is converging. So d beta by ds for a diverging beam will be positive, while we are defining alpha as minus half beta prime, so alpha is negative. So negative sign of alpha shows the diverging beam, and positive sign of alpha shows the converging, means focusing and defocusing. Now for obtaining the physical meaning of gamma, we again write down the expression of constant or invariant of the motion, and we differentiate this equation with respect to x. And when we do this, we get dx prime by dx. If we make it 0, that will give you the maximum of x prime. What is that maximum of x prime? We see it. This is a simple calculation. So gamma x plus alpha x prime will be 0 when we will equate to 0, dx prime dx 0. It will give gamma x plus alpha x prime. This is the maximum value of x prime because we are equating the first derivative to 0. This will be 0, and using this equation we will get this. So what is the value of x at the location of x prime max? We obtain this. Now if we use this value of x in the expression, we will get the complete expression in the form of x prime. So we have converted the whole expression in x prime, so we will find the value of x prime. What is that value? We will see it. This we get gamma beta minus alpha square. However, you know that gamma beta is 1 plus alpha square. So this equation becomes gamma beta minus alpha square is equal to 1 plus alpha square, which is the gamma beta minus alpha square. So this is the 1. So numerator becomes 1, and in denominator we have gamma. So 1 by gamma x prime x square is equal to a square. So x prime max square is gamma a square and x prime max is a. So similar to beta function, which shows the amplitude of the betatron oscillations, gamma shows maximum angle during the betatron oscillation at a particular place. So beta shows the displacement, maximum displacement at a particular location, and at that location, gamma shows the maximum angle trajectory will make with respect to descent trajectory. And alpha relates these two parameters. So alpha generates a correlation between the displacement and angle. So now we can plot an ellipse using gamma x square plus twice alpha x x prime plus beta x prime square is equal to a square. How this ellipse can be plotted? We have seen two methods. In one method, we generate various combination of x x prime corresponding to same a, and that various combination will produce an ellipse, and the area of this ellipse will be pi a square, which is invariant. And second technique is that instead of generating various initial condition, take a single condition in a synchrotron and record its position turn by turn. Definitely you have to record the x prime also for generating the ellipse. So on each turn, when particle crosses the desired location, record x and x prime. And after many turns, when you will connect these points, you will see this is an ellipse. So there are two methods to generate this ellipse. One is combination of various initial conditions. Another is single initial condition but multiple turns. In both cases, you will get the same ellipse. So in this ellipse, the maximum amplitude is up to this point. So this is represented by a root beta. This ellipse is showing the betatron oscillation. So this is the excursion of betatron oscillation in displacement, and this is the excursion of betatron oscillations in the angles. So in angle, the maximum excursion of betatron oscillation at a particular location S, I'm always talking about a particular location, because at another location, this ellipse will be different, because gamma and beta at that location will be different than this, because beta and gamma are the function of S. However, area of this ellipse at that location will be same as the area of this ellipse here, because area is invariant of the motion. Now you can connect this thing with also Liouville's theorem. In classical mechanics, if you study Liouville's theorem, this shows that under the conservative forces, volume in the phase space or density in the phase space remains constant. So it is a similar thing. However, you can say that Liouville's theorem in the phase space, and we are talking about the x and x prime. What is the relation between the x prime and phase space? You can see that x prime is basically the px upon ps. And already we have seen in paraxial approximation that ps is approximately equal to p, and which is a constant because magnet doesn't change the momentum. So x prime is directly proportional to px. So if we say that we are plotting x prime, the similar kind of plotting will be in the x px also in our case. So we say that x prime also represents some kind of phase space. It is strictly known as trace space. The space made by x prime is the trace space. However, because x prime is proportional to px, we can loosely say that this is the phase plot or phase space plots. So this is the plot in the phase space. So Liouville theorem also holds here. However, the Liouville's theorem holds only for conservative system. And here, because we are considering the particle is passing through the conservative magnets, it is also a conservative system because magnets do not change the energy of the particle. However, when acceleration takes place, the area of the ellipse may change, because when acceleration takes place under the time varying electric field, the system is no longer conserved. So in that case, we will see what would be the invariant of motion. And in some cases, when charged particle feels some acceleration, it can radiate. So that is a kind of dissipative forces in the nature, because in the form of radiation, particle loses its energy. So that again becomes non-conservative system. In that case also, area of this ellipse may not remain constant. But in this course, whatever we are studying, we can think that our area of the ellipse remains constant. And in this case, A root beta shows the maximum amplitude of displacement, and A root gamma shows the maximum amplitude in angles. So we have known something about this solving Hill's equation and obtaining the twist parameters. All these books are same, which will cover. Actually, the same reference will cover our entire course. And in next lecture, we will study more on these beam parameters and how we can characterize an optics using these parameters. We will see that in our next lecture.